Welcome to your next training video on systems of equations. Today we're going to look at what if they have three variables and three equations. Now these graphically are very different than two-dimensional systems of equations because they graph planes. Let's look at graphically what the solutions look like. So if you have three planes, this first one that meet at one point, that is one solution where all three planes are at. You're going to get a value for x, you're going to get a value for y, and you're going to get a value for c, and you write your answer like this, -2, 3, and 5. You get one solution. You could get a whole line where they intersect on this axis right here, right? Then you won't get values for x, a value for y, and a value for z. You'll get something like 0 = 0 or infinite solutions. That doesn't mean that they're all the same plane, but it does mean that they all cross on one line. It can mean that they're all the same plane. No solution, look at our different options here. There's nowhere that all three planes are intersecting at the same time. For that, when you're solving, you'll get something like 0 = 4. So if you get either of these two options when you're helping out students, don't freak out. One of them means infinite solutions, or the other one means no solution. All three planes don't cross out. Now let's look at how to find that one answer, right? That one point where all three intersect. So here is an example of three equations, three variables. We want to solve the system. We want to find the x, the y, and the z. That when I plug them in, it will give a true statement for each of these equations. Here's our process, and we'll walk through it with this problem in just a minute. First, there's going to be a lot of elimination in this process. You're going to eliminate one variable twice, and then you're going to use those to eliminate another variable, and then solve for what you have left, and stick everything back in to find what else the other variables, right? So there also are ways to use substitution on this, but it's easier if you can eliminate one variable first. So let's start with step 1 on this problem. All right. The biggest thing I've found with students is just keeping themselves organized and keeping track of what they're doing. So here are some things that I have learned to help students who are trying to learn how to solve systems with three variables. I'll either label them with colors or letters or both. And then within each step, I will write out exactly what I did. So for example, our step 1 is we're going to eliminate one variable twice. It looks nice to eliminate z, so I'm going to add equation A and equation B, add those together, and I get 4x, 3x plus x is 4x, -y plus 2y is 1y, and the z's eliminate. And then I have a -15 plus 1, -14. I have eliminated z once, but I need to eliminate the same variable twice. So let's take two other equations. I'm going to label that one D, by the way. I'm going to take C, because I haven't used that one yet, the equation C, and I'm going to double A so that I can still get rid of Z. So here is 2A, right? It's important to make sure that you multiply every single part by 2, even the constant on the right hand side. Make sure everything gets multiplied, and now I'm going to add it to C, and I get 6x plus 2x is 8x. -2y plus uy is 1y again, and then my z has been eliminated twice now. -30 plus 0 is still -30, and let's go ahead and label this one E. Our next step was to eliminate another variable, so we gotta get rid of x or y, either one, so that we can find the other one. So I'm going to take D and E. It wouldn't help to use A, B, or C because those have a Z in them. We need to use the ones that have just X and Y. So I'm going to take D and I'm going to subtract E from it, or add -1E, so it'll look like this. 4x plus y equals -14. That stayed the same, but then all of these signs changed. So it's -8, -1y, and -30. So it's +30. Add those together. Right? Oh, I didn't put this on I gotta write it. 4x plus -8x is -4x. Those are eliminated. Equals -14 plus 30 is +16. Divide by -4, and I get -4. X equals -4. Solve for the remaining variable, check. Now I need to plug that back in to find y and z. Solve for those last variables. And so I'm going to go back to D or E, doesn't matter which one. I'm going to plug in the x that I know and find y. Again, it would be useful to go back to A, B, or C at this point because I don't know what z equals or y. So I have negative 16 plus y equals negative 14. Add 16 both sides, and y equals positive 2. Ooh. Drop my pen, sorry if that scared you. Y equals 2. Alright, so I have y, and I have x, and I need z. So I'm going to go back to the beginning and plug those in. I'm just going to pick the first one. X equals negative 4, minus y is 2. Don't know what z is. Solve for that. So negative 12 minus 2. Z, negative 15, negative 12 minus 2 is negative 14, plus z, add 14 to both sides, and z equals negative 1. And let's put that all in my point, negative 4, 2, and negative 1. So these three planes from the beginning, plane A, plane B, and plane C, all meet in one point, negative 4, 2, negative 1. Alright, so again, my greatest advice is to find a way that helps your student to organize so they can keep track of what they multiplied by and what did they do to get that step and so forth. Help them to organize it with colors, letters, writing one step on each line, making sure they multiply everything. I want you to try one, follow the steps. Okay, I want you to pause the video and try this one on your own. Okay, welcome back. You should have got negative 2, 1, and 5. If you did not, stick around and watch the rest to see one solution, right? There's lots of different ways to solve these. If you got that, good job. You don't have to watch the rest of the video. Alright, I'm going to go ahead and label these A, B, and C, and I'm going to add, let's do A and C. We're going to eliminate X. Here's one. I'm just writing these out. I'm going to add A plus C, and I get Y minus 3Z equals negative 14. That was helping the student add right. A plus C. Now I need to eliminate X again, so let's go ahead and add 2A, right, multiply that by 2, and B. So I have negative 2x minus 4y minus 2z equals negative 2. Maybe you did a different process when you tried it. That's okay. 2x plus y plus z. Maybe eliminated z first. Alright, add these together and I get, oops, this is the plus. Plus 4y, so that's one of those little mistakes that your students will make. 5y minus 2z plus z is minus z and 0. Okay, you know what, we could even use substitution on this, right? Don't have to use elimination. If I say that y equals negative 14 minus 3z, or sorry, plus 3z, moving that over, and I can plug it in. Ooh, sorry. I just come up with new ideas. Let's do this. Z equals 5y. Right, move that over, divide by negative 1, plug that in here. So y minus 3 times 5y equals negative 14. So that's y minus, ooh, this could be nice. Negative 15y is negative 14y equals negative 14, and y equals 1. So far we have y. There it is. Okay, let's find z. Z equals 5y, so just plug that in. Z is 5. Alright, we found y and z. Let's find x. So put that into equation C. X minus y minus 2z equals negative 13. X minus 11 equals negative 13. Add 11. X equals negative 2. We did it. Hooray. Alright, good luck helping those students with these long systems of equations.